interplay of thermodynamics and quantum fluctuations, there could come a moment when the arrow of time flips, running backward. Cause would follow effect. Stars would unform. Civilizations would crumble into dust, and then the dust itself would reassemble into ancient worlds. It would be a cosmic rewind so alien, so profound, that existence as we know it would become a surreal, broken mirror of itself. Or consider the idea of false memories. The chilling thought that the universe could be so old, so vast, that entire civilizations might be engineered into existence with fabricated memories. You could have been born 5 minutes ago, implanted with every recollection, every scar, every dream, all of it illusions stitched into your mind by the random, merciless chaos of an infinite cosmos. And one of the ultimate cosmic horrors? Existence might not require consciousness at all. In the grand scheme, thinking beings could be a fluke, a temporary, unnecessary glitch in an otherwise mindless, mechanical unfolding of matter and energy. Intelligence, creativity, wonder, mere sparks against the dark, soon extinguished and forgotten by a universe that neither notices nor cares. The more we learn, the more we realize the universe isn't built for comfort. It isn't crafted for survival. It isn't tailored to our hopes, our dreams, or our desperate need for meaning. It simply is a cold, vast, indifferent reality where beauty and terror are inseparably intertwined. Every star that shines is a star destined to die. Every planet that forms is one meteor away from obliteration. Every life that blooms carries within it the seeds of its inevitable end. And yet, we explore, we question, we reach out into the dark. Here, at Whispers of the Cosmos, we lean into that darkness. We listen to the chilling secrets that the stars refuse to shout, but whisper instead. Quiet truths, woven into the fabric of existence. Every terrifying theory, every unimaginable mystery, every cosmic revelation reminds us that we are part of something far bigger, far stranger, and far more breathtaking than we ever dared believe. So we will keep asking, keep seeking, and keep listening to the universe, one whisper at a time. When you think about speed, maybe you imagine a race car, a fighter jet, or even a rocket ripping through Earth's atmosphere. But out there, beyond our tiny blue planet, the cosmos has a whole different idea of speed, a level so extreme it shatters the imagination. Today, we dive headfirst into the most bizarre objects spinning at speeds that make the wildest roller coaster seem like a lazy Sunday drive. Imagine an object no bigger than a city, spinning so fast that if you stood on its surface, you'd be launched into space faster than you could blink. That's the reality of a neutron star, the crushed corpse of a once massive star. When a star dies in a supernova explosion, if the conditions are just right, its core collapses into a sphere so dense it defies our understanding of matter. Some neutron stars, known as millisecond pulsars, rotate hundreds of times per second, 700, even 800 revolutions every tick of the clock. That's faster than the blades of a helicopter, faster than a bullet speeding from a gun. The forces at play are so fierce that the star's crust, an iron shell thicker than Mount Everest is tall, literally cracks and quakes under the strain. But if you think that's crazy, buckle up. There's a particular pulsar out there named PSRJ 1748-2446 AD, the fastest spinning neutron star ever discovered. It rotates at an insane 716 times per second. That's nearly a quarter the speed of light at its equator. If it spun just a little faster, it would tear itself apart. Nature, it seems, loves to live on the edge. And what about white dwarfs? These smoldering, planetary-sized remnants of dead stars are usually calm. But not always. Some white dwarfs spin at blistering speeds, completing a full rotation every few minutes. That's like an object the size of Earth spinning so fast that an entire day lasts less than the time it takes to heat your coffee. These compact beasts maintain incredible rotational energy, trapped in a silent, frozen ballet that's been dancing for billions of years. Now zoom out even further, beyond stars, beyond planets, to the chaotic hearts of galaxies. Supermassive black holes, monsters millions or even billions of times the mass of our Sun, don't just sit there quietly. Some of them spin at near light speed. Picture a singularity, a point of infinite density, wrapped in a whirling maelstrom of space-time itself. At these speeds, the very structure of reality bends around the black hole, twisting magnetic fields, warping space, dragging entire star systems into violent, incandescent orbits. The most extreme among them spins so fast that if you were unlucky enough to fall in, you wouldn't just be swallowed, you'd be twisted and mangled across dimensions as you disappeared into oblivion. But not everything spinning insanely fast has to be massive. In the cosmic junkyard of the solar system, tiny asteroids are doing pirouettes faster than any Olympic figure skater. Some, like asteroid 2008 HJ, rotate completely in under 30 seconds. Imagine a rock hurtling through space, barely 12 meters wide, yet spinning so fast that its surface speeds exceed hundreds of kilometers per hour. If it were made of anything less dense than solid rock, it would disintegrate into a cloud of dust. It's a cosmic tightrope act, with gravity and momentum locked in a perpetual daredevil's handshake. And then there are stars like VFTS 102, a massive blue giant tearing through its rotation at over 2 million kilometers per hour at its equator. That's so fast, its entire structure bulges outward, stretched into an oblate spheroid by centrifugal forces. This is a star, barely holding itself together, living every second on the razor's edge, between cohesion and collapse. It's not just burning hydrogen, it's burning through the limits of physics itself. Finally, let's talk about something you wouldn't expect to make the list: planets. Take Jupiter, for example. Despite its titanic size, a planet so large it could fit over 1,300 Earths inside, Jupiter spins faster than any other planet in the solar system. A single day on Jupiter lasts just about 10 Earth hours. That's like spinning a skyscraper-sized ball of gas and storms at breakneck speed without it flying apart. And it's no gentle whirl either. This rapid rotation powers Jupiter's monstrous storms. Storms so big they could swallow Earth whole, fueled by a spin that just won't quit. In the grand theater of the universe, speed is a currency, and the cosmos spends it with reckless abandon. In neutron stars whirling like cosmic blenders, in asteroids dancing at the edge of destruction, in black holes that twirl space-time into knots. Speed isn't just about motion. It's about the violence, the power, and the sheer unstoppable momentum written into the DNA of the universe itself. But the universe doesn't stop at spinning stars, collapsing cores, and rampaging asteroids. It gets even stranger. It gets wilder. Some objects aren't just spinning fast, they're spinning in ways that defy every rulebook we thought we understood. Take spinning quark stars, theoretical objects even denser than neutron stars. If they exist, they could spin even faster, their surfaces moving at a terrifying fraction of light speed. Inside, the very matter is crushed beyond atoms, into a soup of quarks, the building blocks of protons and neutrons. Imagine an object no bigger than a city, spinning so viciously that space-time itself ripples around it like water around a whirlpool. It's a cosmic blender operating at speeds and densities where physics itself begins to lose meaning. Or picture the fastest spinning brown dwarfs, objects too big to be planets, too small to ignite as stars. Some of these cosmic misfits complete a rotation in just a few hours. They spin so fast that their equators bulge outward, like cosmic belly dancers, puffed up by centrifugal force, defying the smooth, serene faces we associate with stars and planets. These are failed stars partying like it's the end of the universe, flaunting their speed for all of creation to see. Even closer to home, Earth isn't immune to bizarre spin phenomena. Our planet doesn't rotate at a perfectly constant rate. Tiny changes, gravitational tugs from the moon, mass movements of the atmosphere and oceans, cause Earth's spin to wobble, to speed up, to slow down. Earth is engaged in a slow cosmic dance, its spin subtly swaying with the invisible currents of the solar system. It's a reminder that even something as familiar as one day is really a delicate balancing act on a cosmic stage. Then, there are entire galaxies that spin like titanic pinwheels in the night. Take the Cartwheel Galaxy, whose perfect, eerie shape was sculpted by a collision with another galaxy millions of years ago. Its outer ring is spinning outward, pushing through space like a shockwave frozen in time. Entire solar systems are riding that wave, hurled forward by the echoes of a galactic impact, moving through space at speeds beyond imagination. Or consider ultra-fast magnetars, neutron stars born not just spinning fast, but magnetized to the extreme. Their magnetic fields are so powerful, they can slow their insane spin down dramatically within just a few thousand years, blasting energy into the cosmos like galactic lighthouses gone berserk. At birth, they spin so fast, perhaps over 1,000 times per second, that the energy released could outshine an entire galaxy for brief, searing moments. These are cosmic firecrackers, burning bright and dying young, leaving behind ghostly remnants whispering through the void. And while we're at it, let's not forget the accretion disks around young stars. These spinning maelstroms of gas and dust aren't just picturesque. They're high-energy factories where new planets are forged. These disks rotate at staggering speeds, with material moving faster than the speed of sound in gas. Every inch of these swirling disks is a chaotic battle of gravity, pressure, and turbulence, a frantic, furious dance where worlds are born in violence. The universe doesn't just spin, it pirouettes, it whirls, it howls through the endless night with energies and speeds that stretch the very fabric of space and time. Every spinning object out there, from tiny asteroids to monstrous black holes, is a reminder that motion is life, motion is violence, and motion is the heartbeat of the cosmos. The stars don't just burn, the planets don't just orbit, the galaxies don't just drift. They spin, they rage, they scream across the silent emptiness at speeds that mock our puny human understanding of motion. And just when you think the cosmic carousel couldn't spin any faster, quantum mechanics steps into the arena and completely rewrites the rules. At the smallest scales imaginable, particles like electrons and quarks exhibit a strange property called intrinsic spin. Not spin like a planet or a top, but an inborn angular momentum that defies everyday intuition. These fundamental particles are spinning, metaphorically, at impossible speeds, forever locked into a quantum twirl that underpins the very structure of reality. Without this ceaseless, invisible motion, atoms wouldn't hold together, chemistry wouldn't work, life itself wouldn't exist. Even entire clusters of galaxies, unimaginably vast collections of hundreds, even thousands of galaxies, have been caught in the act of rotating slowly over billions of years. Their spins are so colossal, so ancient, that they trace back to the earliest whispers of structure in the universe, seeded in the aftermath of the Big Bang. It's a cosmic inheritance of motion, a momentum handed down through eons, echoing across the darkness. Some theorists even speculate about exotic objects called Gravis stars or boson stars, hypothetical entities that might spin in ways even more exotic than anything we've ever observed, combining extreme mass, rapid rotation, and quantum properties into a cocktail that pushes the very limits of known physics. If these objects exist, they could be the most bizarre and fastest spinning phenomena in all of creation, hidden out there, waiting for our instruments to catch up to their mystery. Rotation is the language of the universe's most extreme and most delicate creations alike, from collapsing giants to newborn stars, from tumbling asteroids to the quantum pirouettes of invisible particles. Spin is a fundamental, inescapable feature of existence. It powers magnetic fields that protect worlds. It sculpts solar systems. It unleashes jets of energy that stretch across millions of light years. In the end, spinning is not just what objects in space do. It's what space itself does. Every whirl and every twirl is a frozen signature of past violence, past creation, past change. The cosmos remembers its history in every turn, every rotation, every impossible spin we glimpse through our telescopes and instruments. It's a universe that never stands still, a universe forever in motion, forever alive. Here at Whispers of the Cosmos, we chase those secret motions, those hidden rotations, those cosmic pirouettes that define the very fabric of existence. Every spin, every pulse, every orbit is a whisper carried across the void, a message from the universe itself. And as long as there are mysteries whirling in the darkness, we'll be here, listening, exploring, and sharing their stories with you, one cosmic whisper at a time. Imagine setting out on a cosmic journey, fueled by wonder, curiosity, and just a hint of madness. The universe is vast and beautiful, but it's also a place of unimaginable dangers. If you think a shark-filled ocean is terrifying, just wait until you see what the cosmos has cooked up. So buckle up, traveler. Today, we venture into the top 5 most dangerous places in the universe to visit. First stop, the surface of a neutron star. Picture this, a city-sized sphere, packing more mass than our entire sun, crushing atoms until they become an ocean of neutrons. Step foot here, if that were even possible, and you'd be flattened instantly by gravity 2 billion times stronger than Earth's. Forget hiking boots, you'd need quantum armor, just to survive the first nanosecond. Time, space, and even the definition of matter itself twists under such pressure. Here, reality bends, and the line between science and science fiction blurs. Next, we drift toward the center of a supermassive black hole. It sounds poetic, spiraling into a cosmic ballet of darkness, but in truth, it's pure annihilation. As you approach, tidal forces stretch you thinner and thinner until you become a single strand of atoms, a phenomenon chillingly named spaghettification. No spaceship, No shield, no desperate scream can save you. You wouldn't even see it coming. The very light carrying the warning signs is swallowed whole, lost to eternity. Crossing the event horizon is a one-way ticket, and no postcards from the other side. Now, let's get adventurous. How about visiting the Bhuta's Void? Sounds harmless, right? Wrong. Imagine a region of space so empty, so utterly devoid of stars, galaxies, and light that it stretches nearly 330 million light-years across, like a cosmic ghost town. Travel here, and you'd find yourself in a cosmic silence so deep, your mind might fracture under the sheer psychological weight. No light, no stars, no beacons to guide you home. Just endless, suffocating darkness, whispering into the folds of your sanity. Feeling brave? Good, because now we're heading to the gamma-ray burst zone. Somewhere out there, massive stars are dying in violent explosions, releasing more energy in a few seconds than our sun will produce over its entire 10 billion-year lifetime. If you happen to be anywhere nearby, and by nearby, I mean hundreds of light-years away, the radiation would incinerate your spacecraft, strip away your atmosphere, and cook your DNA like overdone bacon. You wouldn't even have time to register the flash. You'd simply cease to exist, erased by a silent cosmic bullet traveling at the speed of light. And finally, the crown jewel of cosmic nightmares, the quasar's heart. Imagine a black hole so ravenous that, as it devours entire stars, it spews jets of radiation millions of light-years into space. A quasar's core shines brighter than entire galaxies combined, but approach too close, and you're caught in a maelstrom of lethal particles and magnetic storms. Here, physics goes feral. Gravity becomes a tyrant. Light itself struggles to escape the chaos. Visiting a quasar's core would be like flying into the mouth of an angry god, a blinding fury of energy, soundless but merciless. The universe is breathtaking, yes, but it is also merciless in its indifference. Beauty and terror, intertwined like twin strands of DNA, stitched into the very fabric of existence. And while we gaze up in awe, safely tucked away on our pale blue dot, these cosmic monsters lie in wait, silent, patient, eternal. But danger in the universe isn't always about brute force or cosmic violence. Sometimes it's about environments so alien, so extreme, that they defy the very rules life depends on. Take the atmosphere of a hot Jupiter, giant exoplanets that orbit scorchingly close to their stars. Here, temperatures soar to thousands of degrees, and winds scream at speeds of over 5,000 miles per hour. Iron doesn't just melt, it vaporizes, forming metallic clouds that rain molten droplets from the skies. Imagine standing on a world where the storm clouds aren't water, they're boiling metals, and every breath would ignite your lungs. Even machines wouldn't survive more than a few seconds in that hellish cauldron. Or consider the core of a white dwarf, the smoldering skeleton of a dead star. If you could somehow dig down into this cosmic ember, you'd find something truly bizarre. A mass of crystallized carbon and oxygen, essentially a gigantic diamond floating in space. But don't let its sparkle fool you. The gravitational forces here are so intense that a teaspoon of white dwarf material would weigh as much as a skyscraper. Its beauty forged under unimaginable pressure, a jewel crafted by death itself. Now, imagine venturing into the magnetosphere of a magnetar, the magnetic monster cousins of neutron stars. A magnetar's magnetic field is 1 trillion times stronger than Earth's. Get too close, and it could tear apart the very atoms that make up your body. Not your ship, not your suit, your atoms. It's like nature reached deep into its bag of tricks and pulled out a force so powerful it breaks the rules of matter itself. Just being nearby would scramble your brain's electrical signals before you even knew you were in trouble. And then there's the accretion disk of a black hole, the swirling halo of gas and dust spiraling into oblivion. Temperatures here can rival the cores of stars. The friction alone produces radiation so intense it could sterilize entire regions of space. You wouldn't even need to fall into the black hole to be doomed. Just brushing the edge of its hungry whirlpool would be enough to reduce a spacecraft to its component atoms, scattering them across the event horizon like cosmic confetti. Finally, we can't forget the raw chaos of star-forming nebulae. From a distance, they look majestic, colorful clouds of dust and gas where new stars are born. But inside, it's a battlefield of radiation, shockwaves, and gravity so turbulent that entire planetary systems can be shredded before they even form. Here, destruction and creation dance hand in hand. Step into this cosmic nursery without proper shielding, and the high-energy particles would slice through you like 1,000 invisible knives. Its beauty in its most violent infancy. The universe doesn't hide its dangers behind locked doors. It puts them on full display, dressed in dazzling lights and spectacular phenomena, daring the bold and the curious to come closer. It's a place where survival isn't guaranteed, where the rules you trust to keep you safe are bent, broken, and sometimes erased entirely. Yet despite all of this, despite the peril, the chaos, the unimaginable extremes, we can't look away. Because in every fiery death, every crushing force, every storm of annihilation, the universe reminds us of something profound, that existence itself is a miracle carved from the very heart of chaos. And what about the places where even time itself seems to lose meaning? Imagine wandering too close to the edge of a cosmic string, hypothetical one-dimensional defects in space-time, thinner than an atom, but heavier than a mountain range. Their gravitational pull would be so intense that they could warp space around them like a tornado twisting the sky. One accidental crossing, and you might be hurled across the galaxy, or torn out of existence before you even realized it. Then there's the chaotic realm of colliding galaxies. Two titanic cities of stars, each containing hundreds of billions of suns, smashing together over hundreds of millions of years. It's not just a fireworks show. Gravitational forces rip apart solar systems, black holes spiral toward inevitable confrontation, and radiation storms sweep through the interstellar medium. If you were unlucky enough to be caught in the chaos, no amount of shielding or evasive maneuvering would save you. It would be like trying to survive a demolition derby where every car weighs 1 trillion tons, or dive into the deadly drama of a Type Ia supernova, the ultimate cosmic bomb. When a white dwarf siphons off just enough material from a companion star, it crosses a critical mass limit and detonates in a thermonuclear explosion that can outshine entire galaxies. If your spacecraft were parked nearby, the flood of gamma rays would strip away your protective layers, cook you alive in milliseconds, and erase all traces of your visit. Not even light can outrun the sheer devastation. And lurking in the dark, hidden by shadows, are rogue planets, giant orphan worlds ejected from their parent stars, drifting alone through the void. Their surfaces are frozen, their skies eternally black. No sun, no warmth, no life, just endless night and lethal cold that would sap every last joule of heat from your body until you became a frozen relic, preserved for eternity in a universe that wouldn't even notice you were gone. But perhaps the most chilling threat is something subtler: vacuum decay, a nightmare straight from quantum physics. If our universe exists in a false vacuum, a precarious, unstable state, then somewhere, at any moment, a tiny bubble of true vacuum could spontaneously form and expand at the speed of light. Anything it touches would be wiped clean. Atoms, stars, galaxies, the very laws of physics rewritten. There would be no warning, no escape, no trace. Reality itself would be reprogrammed. The universe is not just a place of wonders. It's a crucible of extremes, where survival is the exception, not the rule. Every sparkling nebula, every swirling black hole, every lonely rogue planet is a chapter in a cosmic story written in the language of creation and destruction. And somehow, against all odds, on one tiny rock orbiting a modest star, life found a foothold and dared to look up. Here at Whispers of the Cosmos, we don't just stare into the night sky. We listen. We listen to the silent roars of black holes, to the echoes of ancient stars, to the deep resonant hum of a universe both terrifying and breathtaking. Every whisper from the cosmos tells a story of danger, of beauty, of endless possibility. And as long as there are mysteries in the sky, we'll be here, listening, wondering, and reaching ever further into the infinite. You think Earth's moon is strange? It's just the beginning. Our solar system is a sprawling carnival of moons, over 200 of them, and they are anything but ordinary. Some are frozen, some are volcanic, some hide oceans, some breathe, some break the rules of planetary science, and some, they shouldn't even exist. Take a seat, buckle your imagination. We're going on a tour of the weirdest, wildest moons orbiting the sun's planetary giants, and each one is more jaw-dropping than the last. Let's start with Io, Jupiter's tortured child, the most volcanic body in the entire solar system. Not one volcano, not 10, over 400 active volcanoes erupting across its surface, lava fountains taller than Everest, sulfur plains glowing orange and yellow. What causes this hellscape? Tidal forces. Jupiter pulls on Io like a celestial taffy, squeezing it, kneading it, heating it from the inside. It's not just geology, it's planetary warfare. And then there's Triton, Neptune's largest moon. But here's the kicker, it orbits backward. Retrograde. It's the only large moon in the solar system that does. That means it didn't form around Neptune. It was captured, an interstellar refugee, caught and chained to a gas giant. Its surface covered in nitrogen ice, but it's not still. Geysers of dark material burst from beneath, spraying miles into the sky. A cold moon, a captured moon, a rebelling moon. Next stop, Mimas, Saturn's moon that looks suspiciously like the Death Star. One massive crater, Herschel crater, gives it a distinctly familiar look, but its weirdness goes deeper. Scientists expected an ocean beneath its surface, based on its shape. But there's no sign of one. Or is there? Its wobble hints at something sloshing inside. Could this frozen cue ball be hiding a secret sea? Speaking of oceans, let's talk about Europa. From the outside, smooth, icy, calm, but beneath that icy shell lies a vast liquid ocean, possibly twice the volume of all of Earth's combined. And where there's water, there could be life. But this isn't just water, it's salty, warm, and restless, stirred by tidal heat. Think about it, a world with no sunlight, no air, and yet the potential for alien microbes swimming beneath a frozen sky. But Europa isn't alone. Its cousin Enceladus is a snow-white jewel orbiting Saturn, and it sprays water into space. That's right, massive plumes erupt from its south pole, launching ice and vapor hundreds of kilometers into the void. NASA flew a spacecraft through the spray and found organic molecules, hydrogen, salts, the ingredients for life, on a tiny moon no wider than Arizona. Something is cooking under that ice. Then there's Phobos, Mars' largest moon, but large is generous. It's irregular, potato-shaped. It orbits Mars so fast, just 7 hours, that it rises in the west and sets in the east, and it's spiraling inward. One day, Phobos will get too close, break apart, and form a ring around Mars. This isn't science fiction, it's orbital destiny. Now shift your eyes to Titan, Saturn's heavyweight moon, bigger than Mercury, shrouded in a thick orange atmosphere, not of oxygen, of nitrogen and methane. It rains liquid methane. Rivers of hydrocarbons snake across its surface. Lakes, seas, even waves. But it's minus 290 degrees Fahrenheit, cold enough to freeze steel. Yet it has weather, seasons, climate. It's the only place in the solar system, besides Earth, known to have standing bodies of liquid. It's alien, but eerily familiar. Let's get weirder. Iapetus, another Saturnian enigma. Half of it is dark as charcoal. The other half is bright as snow. A world split in two. And there's a ridge running along its equator. A mountain range that wraps around the moon like a belt. Where did it come from? No one knows. It looks like a walnut from space. A cosmic oddball with no clear origin story. Now zoom out, way out, to Uranus. Its moon Miranda is a shattered world stitched back together. Cliffs 20 kilometers tall, the tallest in the solar system. Canyons, ridges, and terrain that looks like it was cut and pasted together by an indecisive god. It's as if the moon broke apart, and gravity pulled it back into a Frankenstein shape. A patchwork of chaos orbiting a tilted, icy giant. And finally, the wild card, Pan. Not even spherical, it looks like a ravioli, a literal space ravioli. Why? Because it orbits inside Saturn's rings and has scooped up material around its equator. That ring of debris formed a bulge, a ridge, a pasta-shaped moon that clears a gap in the rings like a tiny cosmic Roomba. Small, bizarre, and totally unique. This is just a glimpse, a glance at the celestial zoo that orbits our planets. These moons aren't just rocks. They're laboratories. They're time capsules. Some are active, some are dead. Some could host alien life. Others are ticking time bombs. They challenge everything we thought we knew about what a moon could be. We often look at planets as the rulers of their orbits, the undisputed sovereigns of the solar system. But these moons, they're the revolutionaries. They don't follow the rules, they rewrite them. Some moons have atmospheres thicker than Mercury's, others have none at all, yet still host violent geological activity. Some are ancient and cratered, bearing the scars of billions of years of cosmic history. Others have surfaces so fresh, so smooth, it's as if they were born yesterday. These aren't static worlds. They evolve, they change, they surprise us. Take the way many of them interact with magnetospheres. For example, Ganymede, Jupiter's largest moon, is not only bigger than Mercury, it's the only moon in the solar system with its own magnetic field. A moon with a magnetic shield. That means auroras, glowing curtains of light, dancing across its icy crust, shaped by the giant planet it orbits. A moon with its own space weather. And let's not forget that some of these moons may not be moons forever. Their orbits decay, their surfaces erode. Some are being stripped apart by radiation. Others may one day escape their planets entirely, set adrift into the void, as rogue objects, cosmic loners, bearing the chemical fingerprints of the systems they once called home. Some moons act like engines, driving the structure of the ring systems around their planets. Shepherd moons like Prometheus and Pandora don't just orbit Saturn, they sculpt its rings, gravitationally herding ice and dust like sheepdogs of the cosmos. Without these moons, Saturn's iconic rings would be chaos. And in a twist of poetic beauty, some moons are the products of cataclysm, likely formed from violent impacts in the ancient solar system. Pieces of shattered worlds coalescing into new bodies. Every ridge, every groove etched into their surface is a page in the history book of celestial